Hello, and welcome to the Johnson Controls Blue Water webinar for October 2022. I am Craig Hanna, and I am grateful to serve as the engineering manager of the Johnson Controls Water Infrastructure Technology team. Our team of subject matter experts is dedicated to designing, installing, and commissioning projects that reduce water loss, that increase water utility staff efficiency, and that decrease operational and maintenance expenditures. In short, our team exists solely to provide your water utility with the critical tools and training it needs to be a well-run organization. Please allow me to introduce to you two of my other teammates, Audrey Noel and Jonathan Gunn. Audrey is our amazing team leader, and she lives in Southern California. I can readily affirm that Audrey is truly a master of databases, and she's also an outstanding project manager. If I had either a mobile AMR or an AMI system project to install, I would want her to lead it. Audrey, would you please tell the audience more about yourself and some of your experiences in the water industry?
Absolutely. Thanks, Greg. I'm Audrey Noel, Director of the Water Infrastructure Technology team here at Johnson Controls. I have 7 years of industry experience, a Juris Doctorate with an emphasis in environmental law, and decades of experience in operations. I have the privilege of leading the team from the sunny shores of Huntington Beach, but I couldn't do it without our very knowledgeable and talented market manager, Jonathan Gunn, who offices just 2,700 miles north and east of me in Canandaigua, New York. Jonathan, tell us a little bit more about your experience, please.
Yeah, thank you. And per our usual, Audrey, we are getting lunch after this, right? It's only a hop, skip, and a jump, 2,700 miles. So, no, good morning. My name is Jonathan Gunn. As Audrey said, I'm a market manager with our water infrastructure team. I have 12 years in the industry, and like Craig, I serve in a number of different capacities within the American Waterworks Association, including as the current chair of the Customer Metering Practices Committee, the chair of the C712 subcommittee, and I also co-author a number of manuals and publications within AWWA. So great to be here with you this morning. We appreciate you joining. And per our usual, believe it or not, we've been at this for almost a year now, better part of a year, and we still have new people showing up each and every month. So in our usual cadence here, for those who may not be familiar with the On24 platform, we did want to take a minute and just show you what you're seeing on your screen. Right in the center here, this is the media player. This is where you're currently seeing my video feed. You see the video feed for the other presenters as we move through the webinar today. To the right of that is the slide deck. This is where you'll see the content for the webinar today, the slide deck as we move through. Below that is the Q&A box. So this is where you can ask us a question at any time. Don't feel like you have to wait until we get to a stoppage where we're looking for Q&A. During the webinar, as soon as something pops into your head, please feel free to submit a question, and we'll put that in the queue so that we can answer it for you during the Q&A session. To the left of that is webinar-related content. So these are documents and files that you can download and read at your leisure that serve as supplemental information to some of the topics that you'll see here today, as well as from past webinars. Up at the upper left there is our book a meeting function. So if there's something where you have a question and you just don't think a Q&A is going to do it, maybe an email is not going to do it, you really just want to talk to somebody here, please set up a meeting with us. We'd love to hear what your challenges are, and more importantly, how we can help you solve those. And last but not least, Donald, on the bottom of your screen, you have the icon bars, or the icons there. Some of those look pretty familiar, such as maybe media player in the slides. I will mention that all of the windows that you see in front of you, you can move them around, you can scale them, make them bigger, smaller, whatever you want to do, really make this experience your own. If in doing so you happen to accidentally get rid of one of those windows, just go down to that icon bar and you can bring it back. You'll also notice there are others, such as emailing us, earning CEU credits, and taking a survey that are not currently up, but we would ask that you use those functions, particularly the survey function. Let us know how we're doing. We're always looking to improve the series. So with all that being said, Craig, do you want to take us through the agenda for this morning?
Yeah, I'll be glad to do that, Jonathan. It would not be a Johnson Controls event if we didn't start with safety. The cooler weather has finally arrived for many of us, which is a very welcome relief after the hot and dry summer that we had this year. But with the cooler weather comes less daylight, however, and that poses some new hazards. Jonathan will be reminding us of some practical steps that we can take to be safe this autumn. Next, our team is here to help you solve some of those pesky line-of-sight communication challenges that may be troubling you and causing your AMR or AMI system not to perform as well as you expected. We will also share some tips for you on troubleshooting your networks. We're thrilled to have George Demosthenes and Ian McLeod of VODA.ai Asset Management Software as our special guests this month. VODA.ai is a relatively new and highly innovative software that uses machine learning and artificial intelligence to accurately predict pipe failures in your water distribution system. The VODA.ai system also determines the likelihood of failure, the consequences of failure, and the approximate cost of replacement of each pipe segment. This software can become an integral part of your capital improvements plan too. And now, I would like to turn the presentation over to the deer slayer himself, Mr. Jonathan Gunn, to tell us more about wildlife and being safe on the road as the days grow shorter.
Thank you, Craig. And yeah, an apt observation there. We'll get to that in a minute. Yeah, for this month's safety moment, we wanted to focus on some hazards which will present themselves over the next month or so, if they haven't already. And this photograph that you see on the slide is a great example of nature's camouflage. If you look close enough, maybe some of you noticed the buck standing on the side of the road, maybe not. And for those who did, perhaps the only reason that you saw the buck was because you saw the doe standing halfway into the road. And as Craig said, unfortunately, I am not the best deer spotter in the world, which is why in my 20 or so years of driving, I've hit 9 deer. Seems to be a hatchback thing. If I drive anything but a hatchback, doesn't seem to be an issue. But it is for this reason that we kind of had a collective chuckle among the team when we decided that I was going to deliver this particular safety update for this month. On the one hand, you could say that I have a lot of experience with what to look for, and on the other hand, maybe you don't want it. Maybe you don't want that advice. But regardless, this is a photo from the summer of 2008. I had a couple of friends and I were driving back from a hockey tournament that we had just won, so we were in pretty good spirits there. But as you can see on the way home, a fairly large buck decided that I needed a new car, because there's one thing you need to spend money on in college, it's another car, right? In the buck's defense, 2 other deer had already tried to take this car out, but my little red Kia was pretty resilient up until this moment. 3rd time's a charm, I guess. I am just grateful that insurance companies classify deer strikes as an act of God, or else I would probably be riding a bicycle year-round, which would not work out too well here in the Northeast. Long story short, do be on the lookout for deer and other wildlife, particularly when you're driving in the dusk, dawn, overnight hours, when visibility is poorest. Matter of fact, 80% of deer strikes occur during those hours. The data on this chart happens to be from New York State, and of all places was compiled by my alma mater of Clarkson University. But the trend that you see here generally holds true for North America and Europe for that matter. And if you look, we're in the last week of October here. That's really when that graph really hits its apex there. It's really starting to gain some momentum there. So definitely a timely message here on the from a data standpoint. Unfortunately, however, deer and other wildlife are not the only hazards to unveil themselves as the season changes. Cooler weather combined with high humidity often creates thick fog and slick roads. Having lived in upstate New York my entire life, definitely familiar with the dangers of dense fog and wet roads, and I know that Audrey is as well from her time living in Kansas City. The key to traveling safely in these conditions is to slow down and turn on both your headlights and your fog lights. Also, make sure that you put your cell phone away until you reach your destination, because driving in fog takes a lot of focus and you simply cannot afford to lose any. It's also getting to be that time of year when it's nice to relax by a nice warm fireplace at the end of a long day, or to smell the aroma of a scented candle in your home. While these items and others help to set a pleasant atmosphere, just remember to have your chimney clean before you light that first fire, and never leave lit candles unattended. Failure to do so may result in a much larger fire that you didn't intend, expect, or want. Just a quick reminder for parents and grandparents, Halloween is only 5 days away at this point, if you can believe that. If you are taking your children or grandchildren trick-or-treating through your neighborhood, please be sure and provide a close escort for those children. Bring a bright flashlight and wear clothing with reflective materials so that motorists can clearly see your group. You may also consider providing an early lesson in taxes to your children as you enjoy a percentage of their earnings. I know I will. All right, so now let's get the most out of your mobile AMR or fixed network AMI system by discussing some of those spooky line of sight communication challenges. We'll begin by explaining a fundamental principle behind radio frequency communications. Radio frequency, or RF transmissions, like those used in AMR and AMI systems, require what's known as line of sight communication. Unfortunately, there are many factors that can adversely affect RF communications, and we're going to cover many of those today, along with strategies on how to overcome those challenges. What line of sight communication really means is that both the transmitter and the receiver are installed in such a way so that the radio waves can pass through the air unimpeded to the receiver, just like an archer shoots an arrow toward a target. The challenge is that these ideal conditions are often not found in the real world. Throughout the years, Craig and I have heard some pretty remarkable comments made, such as, quote, cellular signals never attenuate. There's another one, quote, there is cellular coverage over the entire area. And last but not least, quote, there is no interference on our network. One principle that everyone needs to understand is that the laws of physics are constant. Whether it's a 450 to 470 megahertz, 902 to 928 megahertz, 890 to 960 megahertz, or a cellular network, all transmission frequencies suffer from line-of-sight communication challenges, with no exceptions. Moreover, as transmission frequency increases, such as from 450 megahertz to 4G LTE MCAT1 cellular, having a clear line of sight between the transmitter and the receiver becomes even more important. So in terms of challenges, for starters, free space attenuation will always be one of the greatest challenges in RF communications, and it occurs regardless of if there's an object in the way or not. Free space attenuation means that radio waves weaken with the square of the distance traveled away from the transmitter. This decreasing exponential function means that the radio waves lose steam pretty quickly as they propagate from the transmitter. If free space attenuation wasn't enough, we also have to deal with obstacles between the transmitter and the receiver, which will obstruct the line of sight communication path. One of the biggest factors when considering the possible effects of these obstacles depends on whether or not the obstacle is a conductor. If the obstacle is a conductor, the radio wave may be reflected, refracted, scattered, or diffracted. Reflection occurs when the signal cannot pass through an object, so it is stopped and then reflected back toward the transmitter. Scattering also occurs when the signal cannot pass through an object. However, the signal is reflected into multiple new signals instead of a single signal, like what happens during reflection. Refraction occurs when the signal cannot cleanly pass through an object, so the signal becomes bent as it passes through. And diffraction occurs when the signal is spread out as a result of passing through a narrow aperture or across an edge. If an obstacle is not a conductor, some of the energy in the wave will experience absorption by the medium. And it's at this point that I'm going to hand it over to Audrey to walk us through some examples of absorption and how those can be mitigated. Audrey?
Sure, Jonathan. Well, basically, any non-conducting objects between the antennas of the transmitter and the receiver will absorb some of the signal. Large, dense objects, such as thick concrete walls, especially those without windows, as well as concrete and brick buildings, tend to significantly absorb energy from a radio frequency transmission. Whenever possible, we strongly recommend that you drill a small hole through either the mortar or through the cement, run the register cables through that hole, and then mount the endpoint on a wall on the outside of the building. Use a pliable sealant to fill in both the outside and the inside holes of that register cable. We know very well from decades of experience that this can be a challenge at residences with finished basements. No one wants to see a register cable running along the walls or ceiling of such a nicely finished space like that showed in this image. With finished basements, we suggest that you mount the endpoint as high in the rafters as possible and preferably close to an outside wall. Finished basements can make for a very challenging installation, especially with AMI systems that communicate on the cellular frequency. Worst case, it may be necessary to leave some residences on a mobile AMR system if a suitable method cannot be found to transmit through the basement to the nearest cell tower, collector, or router. Trees and foliage can most certainly absorb significant amounts of energy from radio frequency transmissions. Wet trees such as pines, weeping willows, and cedars will absorb much more energy than dry trees such as elms, hickory, or oaks. Moreover, absorption characteristics will change seasonally. Trees absorb much more energy from radio frequency waves in the summer due to the leaves. For those of you who live in areas with pit and vault set water meters, it's so important that you keep the area around the lids clean all year long. Residents have been known to layer tree bark, mulch, and even dirt on top of the meter box. I'll never forget this one project where we installed a new water meter and an endpoint at a residence, and it was communicating just fine for a few days. Suddenly, the endpoint just stopped transmitting. When we investigated that service, we found that the homeowner had placed one of those whiskey half barrels that people use for planters on top of the meter box and planted flowers because the new water meter box was just ugly. In the summer, thick, tall grass around the meter box will absorb energy. And in the fall, leaves, and especially wet leaves, along with pine needles, will also absorb energy. For best AMR and AMI system performance, keep the area around your meter box and vaults clean and clear. Flooded meter pits and vaults are a major problem with radio frequency transmission and reception. Depending on the salinity of the water, signal strength is reduced from at least 40% and up to 60% for every centimeter or 0.4 inches of liquid water through which that signal must travel. That's why it's so important, especially with AMI system networks, that the endpoint be mounted either through the lid for metal lids or directly underneath the polymer lid. Rain and fog can adversely affect radio frequency transmissions. Rain and fog can create both absorption and scattering of the RF signal, but the effects are highly frequency dependent. For 902 to 928 megahertz frequencies, the effect is less than 0.1 decibels per kilometer, even at the highest precipitation rates. If you have a mobile AMR system, however, it's not even a good idea to read meters during times of dense fog or rain, simply because of your workers' safety. Snow buildup around a transmitter causes some degradation in signal strength. For 902 to 928 megahertz frequencies, fallen snow can reduce signal strength by between 0.1 and 2 decibels per centimeter of snow, depending upon both the wetness and the degree of compaction. For northern climates, under a sustained snow load, it's reasonable to assume a 0.5 decibel decrease. In summary, fallen snow can reduce your signal strength from between 2.3% and 36.9% per centimeter. The best practice is to always mount the endpoint on the outside of a wall and above the normal snowdrift line. Now, how does atmospheric discharge or lightning affect AMR or AMI system performance? I'd like to take a minute to have you all select one of these options, your best guess. Is it like static on an AM radio? Does it scramble frequency communications in the immediate vicinity? Or does it only last a few hundred milliseconds? I'll give this one a few minutes. Jonathan, no guessing. You've already seen the show. All right, let's see what we've selected here. Good job, guys. So let's review this real quick. Atmospheric discharge or lightning is only problematic if there's a direct strike on network infrastructure, such as a collector, router, or cellular tower. There's so much energy in a lightning strike that very few electrical devices can withstand a direct strike. If the lightning bolt passes close enough to a device, it may induce electromagnetic field coupling that can cause unit failure. Interference with radio signals may also occur in an atmospheric discharge, but the disruption is very minimal, since a lightning event lasts for less than 100 milliseconds. Well, Jonathan, I think I've thoroughly covered absorption. Would you mind covering some of the other radio frequency communication challenges that a utility may encounter?
Absolutely, yeah. Great job, and thank you, Audrey. So earlier we discussed effects such as reflection, refraction, diffraction, and scattering. Well, metal meter pit and vault lids pose a significant challenge to radio frequency communication in an AMR or an AMI system. And they also happen to be one of the easiest obstacles to identify because it's right there at the meter. To help overcome this challenge, we recommend that the endpoint be mounted as high as possible in the vault and that you always use a through-the-lid antenna. Historically, Customers that implement a mobile AMR system don't see immediate value in this step, since the vehicle-mounted mobile collector will likely get close enough to the endpoint that it will obtain the read and overcome the RF challenge that is posed by the metal lid. However, we do recommend that even with a mobile AMR system, you use a through-the-lid antenna for 2 reasons. First, using a through-the-lid antenna will give you the best overall performance for your mobile AMR system. And second, you may choose at some point in the future to migrate from a mobile AMR system to a fixed network AMI system. And you can save yourself a lot of extra work and undue hassle by not having to return to these locations to relocate the endpoints, and or you may avoid the need to purchase additional AMI system infrastructure in order to overcome the additional RF challenges, which will save you some money. An alternative solution to using a through-the-lid antenna is to replace the existing metal lid with a polymer composite lid. This, however, may be more expensive than using a through-the-lid antenna, and it may be challenging to find replacement lids if your utility uses a wide variety and size of meter boxes. If you replace an existing meter lid with a polymer lid, make certain that the lid has a locking feature and or is weighted if it is to be installed in a flood-prone area, because polymer lids are positively buoyant. A third possible solution that would be appropriate for a setting like the one shown in the photograph on the left would be to bore a hole through the side of the vault wall, run the register cables through that hole, excavate a small section of sod adjacent to that hole, and install a small irrigation valve box and lid. You would then mount the endpoint on either a section of rebar, half-inch PVC pipe, or fiberglass rod inside the irrigation valve box. Meter vaults in parking lots and roadways pose many RF challenges. Obviously, a vehicle that is parked on top of the meter vault will block radio frequency transmissions, and we strongly recommend against ever setting a water meter in a driveway, roadway, or parking lot for that reason. Beyond that, there is the issue of the traffic-rated lids, which are almost always either steel or cast iron, which will also block radio frequency transmission. Thankfully, we've developed a few different solutions to help you overcome this challenge. If there is an existing isolation valve box with a standard 5 1/4 inch cast iron lid, Non-Pop Lids by SW Services does have a traffic-rated polymer lid that you can use in place of a cast iron lid. Just be sure to mount that endpoint as close to the lid as possible. If there's no existing isolation valve box, an alternative solution would be to cut one in. Cut a 5 1/4 inch valve box with a polymer cover into the pavement above the vault, and again, make sure to mount the endpoint as close to the polymer cover as possible. Lastly, if there's a right-of-way adjacent to the vault that is sodded, you can always install a version or an iteration of what we talked about on the last slide, where you bore a small hole through the vault wall, run the register cable through that hole, and mount the endpoint in a small irrigation valve box that is placed in that right-of-way. Houses with aluminum siding can make RF communications very challenging as well. When installing AMR or AMI system endpoints on residences with aluminum siding or on metal buildings, always mount the endpoint on the outside of the building. Failure to do so will only invite an immediate obstacle to the line of sight communication that is required and will affect the performance of your system. Quick question here for the group. Why can you safely look through the door of a microwave even when it's in operation? Shouldn't your blood start heating up as well? We're glad it doesn't, but why is it that you can look through the door? Is it A, you should never really look through the door when it's on. It's just really to check and see if something's on fire or not. B, the tin of the glass blocks out just enough of the radiation for it to be safe. Just don't stand there too long. Or C, the microwave wavelength is longer than the diameter of the holes, so the metal mesh on the glass will reflect that radiation back into the microwave. Same to you, Audrey. You already saw the show. You can't answer. Or Craig.
I always heat up my microwave.
Me too. Preheat that. I'm a big fan. All right. Seeing some responses coming in here. I'll give it another 5 seconds. 4, 3. Submit your answers. 2, 1. There we go. Another flurry at the end there. All right. All right. Most of you said C. So keep this question and this answer in the back of your head. There's a purpose for it, I promise. So buildings with metal lath and plaster construction make for radio frequency communications nightmare. the metal lath can effectively form a Faraday cage around the structure that keeps wireless signals from being transmitted or received. It also serves to both reflect and scatter RF transmissions from other endpoints in the neighborhood. On one of our AMI system projects in Michigan, much of the downtown district used metal lath and plaster construction, and it was quite an engineering challenge to find the right combination of endpoint mountings, as well as both the quantity and locations of repeaters and collectors that were needed to have a well-performing AMI system in that area. Endpoints must be installed on the outside wall of these locations. When installing an endpoint, be sure to take a look around as well. Be cognizant of other objects around you which may affect RF transmission, such as perhaps a giant welded steel propane tank that is located nearby. Be sure to mount the endpoint in such a way that the propane tank or other obstacle will not interfere with radio frequency transmission. Chain link fences are always a challenge for RF communication and reception, and for a similar reason to metal lath and plaster that we discussed earlier. You effectively create a Faraday cage. The image that you see is from one of our projects in Texas, where the utility installed a very high chain link fence around the entire water meter setting in order to protect it. Unfortunately, they also created an RF nightmare. In order to overcome this, our very own Craig Hanna designed an aluminum bracket that securely clamped to the top rail of the fence. And this bracket held two endpoints. It was a compound meter, so it needed two endpoints in this system. And it held those endpoints both above and outside of the fence in order to facilitate radio frequency transmission. Good job, Craig. Other types of metal fences and walls can also cause RF communication challenges, especially if the meter is set directly in front of the fence. It's difficult to predict how much the proximity of either a metal wall or a fence will affect communications until the endpoint is installed, but you should be prepared to reposition the endpoint to a different location. In each of these two examples that you see on the slide here, it may be necessary to mount the endpoint high on either the brick columns or the metal itself. Regardless of the manufacturer, the handheld computer used to program the endpoint should provide a reading of the signal strength, so you will know if the endpoint needs to be repositioned before you leave the site. Large metal structures, such as elevated storage tanks and bridges, can wreak havoc on network performance. For example, here, the Blue Water Bridge in Port Huron, Michigan, that you see in this photograph, required us to effectively build two different AMI systems for the city, one for the north side and one for the south side of the bridge. The radio frequency waves simply could not pass through the metal truss structure of the bridge. This image is from one of our California projects. This water meter box is installed in a sidewalk near the main entrance to a church, and the meter box has a steel lid. You really have a decision to make in installations like these. You can choose to burn a hole through the steel lid and mount a through the lid antenna, but that may create a tripping hazard, particularly in this case since it's in a very high pedestrian traffic area. Or you can choose to bore a hole underneath the sidewalk, run the register cable through that hole, and then mount the endpoint in that valve box with the green cover that you see in the grass. But that may take a lot of time and effort to bore that distance underneath the sidewalk. Depending on the AMI manufacturer that you choose, there may be a third option as well. If your AMR or AMI system offers a buddy mode, you can install one endpoint in the meter box and another endpoint in the valve box. The data from the endpoint in the meter box will short hop to the endpoint in the valve box, and you'll be able to successfully relay the signal to the collector or repeater without creating a tripping hazard and without having to bore underneath the sidewalk to run register cables. We find that many folks don't see bodies of water as a potential obstacle, since water tends to be nice and flat compared to other obstacles that we run into. However, it is good to know that radio signals traveling over bodies of water, or even relatively smooth ground in some cases, can also experience ground reflections, which may cause a challenge for your RF transmissions. Additions or removals of various objects in that area, such as new or renovated buildings and changes in landscaping, will affect RF transmission. Whenever an endpoint stops communicating for more than 72 consecutive hours, we recommend you generate a work order and dispatch a technician to investigate. You may need to temporarily reposition an endpoint for a renovation project, like that shown in this photograph. But if it's new construction or new landscaping that's been installed and it's not going anywhere and it's interfering with endpoint transmission and reception, you may need to both reposition endpoints and possibly add a repeater, collector, or router to your AMI network in order to get that read. So this is where I'm going to ask you to think back to that poll question we talked about a minute ago. Why can you look through a microwave, right? Well, we discussed a number of other solutions, but we fully recognize that sometimes those are simply not realistic for a given situation. And thankfully, there is an alternative method that you may try. Using a cutting torch, you can burn a series of 1-inch wide slits through the lid above where the endpoint would be mounted. As you can see from the chart, the length of that slit is very, very specific, since it aligns with the wavelength of the transmission frequency from your selected AMR or AMI system endpoint. And we've experienced a lot of success on past projects using this method when other solutions were simply not practical. And again, it goes back to the microwave, right? If they drilled those holes in the metal mesh a little bit differently in a microwave, maybe anybody who thought answer A was the reason, where maybe you really don't check it unless it's off, you'd probably be right. But in this case, it is possible to do exactly the opposite of the microwave and intentionally let waves through. All right, so Audrey, you've led, as Craig said, installation of many successful projects. What have I missed here? You know, there must be something. Are there any parting thoughts on installation that you want to share?
Well, I guess, Jonathan, I'd like to remind the audience that parts availability and product support from the original equipment manufacturer for retrofitting encoder registers may be challenging, if not impossible these days. Manufacturers have discontinued many of their older product lines, and a suitable replacement simply may not be available. I'd also like to state that connecting an existing mechanical encoder register to an AMI system may create some unanticipated challenges. On one of our projects, the mechanical encoder registers simply stopped working once they were connected to the AMI system endpoint. Neither we nor the water meter manufacturer could explain why the registers all stopped working, but they did. Not all AMR and AMI system providers are water meter agnostic, and certain water meters and or encoder registers may not be compatible with that reading network. That is why one of the many values that Johnson Controls provides to you is because we do that critical research on compatibility as part of our project development. While we don't have time today to go into the many advantages of using an absolute encoder register over a pulse encoder register, I will say that it is in your best interest to replace those existing pulse encoder registers with new absolute encoder registers. And lastly, there is also the issue of register resolution. Are you satisfied in having only 6 register digits transmitted when you may now have either 8 or 9 digits transmitted? While we're on the subject of connecting existing registers to an AMR or AMI system endpoint, it is critically important that you use the correct tools and procedures for making a field splice. The image at the right is not a proper splice, even though the installer thought it was. You should never use regular pliers on a gel cap splice. And I've also seen installers who didn't know that you had to use those special gel cap splicing pliers at all. These installers assume that all you needed to do was insert the wires into the holes on the bottom of the gel cap. This is one of Craig's favorite pictures.
Yeah. Mm-hmm.
Lastly, make sure that the handheld computers used to program the endpoints are themselves programmed correctly with the proper units and meter multipliers. Never forget that a compound meter will need 2 registers and that both registers need to be connected to an endpoint. Now, before Craig introduces our friends from VODA.ai to talk about their very innovative asset management software, let's pause for any questions that you guys might have. And Craig, would you please introduce the team from VODA.ai?
Well,
see if we have
Audrey, Audrey, if I may, we actually have 4 questions from the audience. And the first question is, we are having issues with AMR and AMI not picking up readings due to metal lids, dirt, or ants in the box, water in the box. Will cellular endpoints help with these issues? And without knowing your exact situation, I'd have to say most likely not. The key for any AMI system transmission in a vault set is getting that signal outside the vault. And so I would strongly recommend either a through the pit lid antenna or replacing it with a composite a composite lid, so that you can get that signal out. As Jonathan said earlier, the laws of physics remain the same, and you've got to get that signal out of the vault. Our next question is, what is your opinion of metering devices with the communication antenna built into the meter? And I'll comment on this first, and then I'll ask Jonathan and Audrey to give their opinion. But I think it's been our experience that there are some advantages to having an integrated endpoint and register, in that it makes installation easier, and there's also no wires to become damaged or possibly tampered with by the end user. But the challenges occur when you're in a pit or vault set environment, in that you cannot, I won't say you cannot, but it will make getting the signal outside of the meter box or meter vault more challenging. And so I always like to have a system where I have the option for an external antenna or maybe an external transmitter. Audrey, Jonathan, is there anything you want to add to that?
No, I'd say you covered it, Craig. I would say it's much easier on the data integration side to not have to QC which endpoint is matched up with which meter, but then you have the challenges operationally after the fact, such as you brought up.
Yeah. The only thing I'll add, Craig, and a great summary, I definitely agree. If you're down south where everything's in a pit outside, I mean, maybe you can get away with a little bit easier. The pits are a lot shallower, in the south. But if you're up in, the north like I am, if and when you run into a meter that's located in a vault, most of them are inside the basements of buildings and homes. But, when you do run into one that's in a vault, usually that vault's going to be 6-7 feet at least down, maybe toward 8 to 10. So, just getting that signal out of that vault may be pretty challenging. So, I agree with you, Craig, 100% to try and select something where you at least have an option to have a through the lid antenna or something similar, or else you maybe find yourself spending more money on infrastructure for your system.
Absolutely. And one thing I neglected to mention in my response, Jonathan and Audrey, is that if fire ants are an issue, there are protective cables that you can use to wrap the register cable in that will basically protect it against fire ants and other rodents. Another question we had real quickly, I know we're running out of time. Yes, buddy mode, it's BUDDY. That is the term for one endpoint short hopping to another endpoint, and some AMR and AMI systems do offer buddy mode, but not all of them. And I think we'll get to I know there are other questions out there, and what we will do, with your permission, is we will just contact you via email after the webinar and answer those other questions, because right now we need to move on to our guests today, George Demosthenes and Ian McLeod of VODA.ai, and we are so glad to have you as our guest today. George, you're the CEO of VODA.ai, and you have a master's in management from Harvard, double degrees in management information systems and industrial operations management from the University of North Carolina in Charlotte. What else would you like for us to know about you?
Craig, it's a pleasure to be with you all today. My background has been working with water utilities over the last 12 years. The first 7 years I worked at a large public company that offered solutions to water utilities, AMI, AMR, fixed leak detection, and condition assessment. I was responsible for the software side of things. And for the last 5 years, I've been leading VODA.ai, where we're helping water utilities with risk modeling and risk mitigation.
Okay, and Ian, you and I have known each other for nearly 2 decades, and it's always been a pleasure to work with you through these many years. And you have a BA in East Asian Studies from USC and an International Studies Diploma from Waseda University in Tokyo, and you also completed the Advanced Marketing Certificate Program from the Cox School of Business at SMU. That's a pretty diverse background. How did you get into the water industry, and is there anything else you'd like for us to know about you?
Well, I got into the water industry because my dad told me, he said, son, you were made to sell. And he said to go find a job. And I fell into it. And then I loved it. I fell in love with the industry. Great people and great technology. And we're doing great things that need to be done for water resiliency and so forth. So it's exciting. And, you know, it's interesting. The first part of our topic today is AMR and AMI. I actually left a leader in the industry in that space to come to VODA just earlier this year because of the excitement of artificial intelligence and machine learning. And so it's great to be here, and I appreciate the opportunity to share.
We're so glad to have you, and I agree with you completely. It's a great industry, and that's why we've been around for so long. It's just a great industry, and we now have a very short video from VODA to show you. It will be in your video screen, and you may need to adjust your sound depending on your computer and monitor and such. But anyway, here's a video from VODA. Well, George, you have to tell us, where did you get the idea? What is the origin story behind VODA.ai?
Sure, Craig. In 2017, I had one afternoon coffee with a former professor of mine, and I shared what I was frequently hearing from utility engineers around the country, which was that the solutions that the industry offered at the time for leak detection monitoring, condition assessment, and so on were great, but it was nearly impossible to install them everywhere. So utilities would spend a lot of money on monitoring their systems or changing pipe, but they would realize that after they spend this money to, let's say, dig out a pipe and replace it, a lot of that pipe that they replaced still had a lot of life left. So there was a lot of waste, and yet there were still a lot of failures in the systems, and that caused an issue. So I shared this with that former professor of mine, and he said to me, George, I know that water is a scarce resource, it's increasingly becoming more expensive, and I'd like to help you. I said, how can you help? You don't know anything about water. He said, well, I founded and sold a business in the medical industry that was using predictive analytics to identify patients with a high likelihood of a health event like diabetes or heart attack. Let's do the same thing for pipes. And that's how we got started. His name is Jim Fitchett, and this is a picture of us the first week when we started back in 2017. Now, 5 years later, we're fortunate to have a team that is across 6 countries, customers that are across 6 countries, and several leading utilities of the world as utility partners. But this is how we got started, Craig.
Oh, that's a truly fascinating story. Now, what are the goals of VODA?
Sure. So when it comes to buried pipes for utilities, it's all about crushing risk, all about mitigating that risk the risk of not having catastrophic failures, but also the risk of not replacing pipe that is good pipe. So if we look at what mitigating risk is beyond those two things, is less pipe failures, it's going to be less cost for the utility, less disruptions, less bad press, and ultimately happier employees at the utility. And that's really the reason we exist, is to help water utility engineers and managers.
Well, I know that there are many different methods, many different programs out there for asset management. Can you tell us what is unique about VODA that differentiates itself from the other programs and softwares?
Yeah, so I'd say there are a few things that are unique. The number one is effectiveness, how accurate this is. We spent many years and a lot of money, millions of dollars, in developing an artificial intelligence engine we call Da Vinci. We developed it here in Boston, and it's specifically made for water utilities. We think it's the most accurate AI engine in the world. And part of it is because we analyzed over 1 million miles of pipe where Da Vinci learned so much from. The platform is really easy to use, and that's the second reason why I think this differentiates us. As the new generation becomes lead engineers and managers in water utilities, they expect things to be easy. You don't need to have special degrees in order to be able to figure out software. It needs to be as easy as social media and tools that we're used to using every day. And we spend a lot of time working on the user experience. And then finally, the platform that we created is the only platform that not only assesses risk for pipe failures, but also determines the probability of service lines having lead material. And when you combine these two, as a utility, it allows you to create plans that are more comprehensive. So you don't have to create a plan to replace distribution mains and then a plan to replace service lines. You can do all of it at once on the same platform.
Wow, that's amazing. Now, could you describe the VODA approach to risk modeling, where risk modeling is equal to the likelihood of failure plus the consequences of failure plus the business risk exposure?
Sure. So it all starts with the likelihood of failure. That's the heart of the solution, where Da Vinci is able to look at the historical failures that the utility had, the GIS data that the utility has, where the pipes are located and so on and so forth, their age, and some other things, and then assigns a probability of failure score for each pipe segment, and that's what we call the LOF, or likelihood of failure. Now, that's half the story, and that's 100% using artificial intelligence, non-human biased, which is, as you probably know, when a human tries to figure out which pipes will fail, will be biased on pipes that failed in the past. But what AI does, it considers that, but it does a really good job at finding pipes that never failed before and they're about to fail for the first time, leaks or breaks. So that starts with the LOF. But the second piece of the story is the consequence of failure. If a pipe does fail, how important is that pipe? Is the pipe in front of the White House or in the middle of the field? So that considers hospitals, hotels, schools, care centers, and goes on and on. That's the second piece. And according to the AWWA standards, when you combine those two, you get the total risk. Business risk exposure is what the AWWA calls it, and we call it the same thing, and that's the BRE. So that's where we end up with the total risk for each pipe segment. It's prioritized, as you see it here on the screenshot of the software. And then we use Planner to create projects that are based on total risk. And there will be some projects that are based on total risk, the VRE, some other projects that may be based on LOF. So if you have leak detection monitoring, you might be more interested in which pipes will fail so you can catch more leaks and lower your non-revenue water. But this is the at the high level, the process.
George, could you just touch on one thing so people understand that if there's any sensors that need to be deployed in the field, or is this purely a data solution, data-oriented solution?
Yeah, that's very important. So DaVinci is very flexible in allowing any type of data to come in, whether it's pressure data, EMI data, any type of data to come in, and it will analyze it. But it does not require any sensors. The minimum requirements, data requirements, are GIS data and historical failures, at least 3 years. If those two pieces of information are provided by the utility, the rest, VODA.ai has hooks with several governmental agencies to get public data. And then we have proprietary data that we include. So data is good, and we will try anything that we can get our hands on, but there aren't any sensors required. This is software as a service, and it can be deployed anywhere where there is internet and GIS.
Now, George, you've told me that VODA is able to calculate the top 1% of pipe failure up to 65 times more accurately than traditional methods. And I have to ask, how are you able to offer such a high degree of accuracy?
Yeah, so Craig, what we found from our analysis over that million miles of pipe we analyzed is that water utilities traditionally have used, most of water utilities have used two types of prioritization method. The most common one is the historical failures method, which says if a pipe failed before, it will likely fail again. So those are the bad pipes. And that's where the utilities focus their resources. That's a good approach. It works, but it is not as effective because it doesn't take into consideration so many other things, like age, like where the pipe is located. Is it near water bodies or near railroads that they may have some additional vibration, and so on and so forth. Some other utilities are using age alone, which what we found is that age is probably the worst single variable you can use on its own. Now, if you use it with historical failures and you use it with so many other variables that AI uses, then you can be much more accurate, and in some cases, 65 times more accurate than age alone. So DaVinci takes the age, the historical failures, proximity to railroads, soil, water bodies, and it goes on. And imagine having all these variables as columns in a spreadsheet, just to make it simple. You see all these variables on a spreadsheet, and you have 250,000 rows for each pipe segment. You open it up, and as a human, when you look at that, it's going to be impossible to figure out patterns. But the AI can figure them out because it will learn from previous failures, not necessarily the causality, but the pattern that led to previous failures. It learns from those patterns, and because it uses machine learning, which essentially is an algorithm that keeps improving on its own. It doesn't require an engineer to go keep changing it all the time. The algorithm keeps improving with more data. And that's how it's able to get up to 65 times more accuracy when you look at the top 1% in comparison with the age or other methods.
Wow. Okay, well, I have to say the Hour Planner suite of software is very impressive. And let's first talk about the leak monitoring. What can you tell us about that particular offering?
Sure. So after we do the LOF, COF, BRE, then utilities can take Planner, and there are different modules within Planner. One of them is leak monitoring. And if you're going to use leak monitoring, you want to use it at your riskiest pipes. So rather than using it on historical failed pipes, the bad areas, you want to use this. And this screenshot shows you how these projects were recommended by Da Vinci. They are optimized and prioritized. The utility can select the leak detection company they're working with, like Ecologics or Orbis or others, or use custom data, and it will recommend which hydrants to use in order to be the most effective.
Okay. Well, your condition assessment planner includes a partnership with Ecologics for field condition assessment on metallic pipes. And I gotta say, what do water utilities need to know about your condition assessment planner? And then I have to ask the question, since Ecologics is not configured to work on polymer pipe, what are your recommendations for conditional assessments on that type of pipe?
Sure. So condition assessment works with Planner in a similar fashion. You add the settings and the business rules, and it recommends projects. Now, what we found is that most utilities do not use condition assessment equipment, but those that do save a lot of money because they focus on the areas with the highest chance of failing. And they have some criteria. They might say, if it's under the highway and it's a large pipe, then we want to do condition assessment because before replacing it, you want to take that extra step because in some cases, you may not need to replace it. So we think that we are confident, we have data to back up that utilities that do use condition assessment save a lot of money. Now, in the business settings within Planner, you can add what those criteria are and exclude certain pipes with material like polymer. And those pipes can go with leak detection, lift and shift, which supports those types of material. So it really depends what type of material you have, all that goes into the settings, and the system is smart enough to categorize and give you the appropriate project and identify the appropriate pipes.
Well, I got to tell you, I surely wish that I could have used your capital planner when I worked for a city government when I was in college. It would have saved me so much time, and I know that it would have been far more accurate than my crude spreadsheet estimations and map markings. And what would you like for us to know about the capital planner offering?
Sure. You know, Craig, there have been planners for cities since the beginning of time, since cities were invented, right? Mm-hmm. A lot of bright engineers out there. But the technology, the automation, the machine learning, the easiness and effectiveness wasn't there all along. So now utility engineers can take this tool and use it in an automated fashion where it allows them to take plans and add them, use the project planner, and then add them on a report like the one you're seeing here within minutes instead of weeks or months, and send this for approval to their board or city council or management. We're just making it easier for them. And it's all about automation and standardization. So it's all making the lives of engineers a little bit easier.
Yeah, where were you back in the late 80s when I could have used you? But I know that you now offer a lead planner that includes both lead pipe management and lead pipe inventory. And please tell us how VODA can be a less expensive and non-invasive alternative to physically surveying and sampling for lead pipes in your distribution system.
Sure. So earlier this year, we've been working on this actually for a couple of years, but earlier this year, we came out with this new solution called VODA.ai Lead Finder, which essentially focuses on those service lines that are unknown on the public side as well as the private side. And utilities have the biggest problems on the private side. So we help them with those unknowns by analyzing the data with Da Vinci, whatever data they have available, and then following the APA process, of course, along the way, but recommending service lines with the highest probability of having lead. And as you can see here, it selects the highest service laterals, the highest probability of lead, and we ultimately help them create their inventory. And this saves a lot of money. In fact, our data shows that we can save at least half of the field visits by using machine learning. And machine learning now is accepted by many states around the country as the way to submit the inventory.
Excellent. Well, we've covered much in our discussion with you today, but is there anything else that that we neglected to cover or that you'd like to mention?
You know, Craig,
Yeah,
I would just
a final
add
thought.
Oh, go ahead, George. No, go ahead, George.
Well, I was just going to say that artificial intelligence is everywhere. I think everyone now sees it on the consumer side, whether it's Tesla or Amazon or Uber, and it's great. But I should mention that it's not only the technology, it's also the human intelligence. We have a lot of bright engineers, PhDs, that are doing a lot of work to make sure that the data is clean, because without clean data, you can't get far, and organizing that data so that the machine learning can take advantage of it and create these insights. So I will leave you with that, Ian.
I was just going to simply say that we focused on the platform, the functionality, and the incredible AI science behind it, but there's also a human element. And when we hear about artificial intelligence and machine learning, sometimes people might think there's not human power behind it. And it's our team of incredible data scientists, I think, that in their ability to clean and process and pair the data together, that is effectively elevated the overall accuracy of our model and our solution. And so I just want to make sure that people understand, in addition to all of the other science behind it, there's data science powered by human data scientists, and that's the key.
All right. Well, thank you, George and Ian. As everyone could tell, we're almost out of time. So what I would like to do, if it's okay with everyone, if you have questions for George or Ian about the VODA asset management software, just please put them in the Q&A module on the chat, and then we will forward those to George and Ian, and they will get right back to you. So please put your questions for George and Ian in the Q&A module on your console. And I got to thank George and Ian for coming today. Great segment on asset management. And you know, we've been promising you for a long time. We've been teasing you. I know, I'm sorry about that, but we've been promising you that we would cover what causes a water meter to lose its accuracy prematurely for many months now, and we're going to finally deliver on that promise. So what we share with you on this webinar will help you to select the best water meter for your unique water source and treatment processes. And our good friends from Master Meter will be joining us to present their intuitive and very innovative product line. And we're also excited that we will have Keith Alexander and Randy Miller from the city of Decatur, Illinois, as our special guests. Keith and Randy will be telling us about their water meter and AMI system project and how it has benefited everyone in the city of Decatur. And again, we would like to thank both George Demosthenes and Ian McLeod of VODA for joining us today. Please invite your friends and colleagues to attend the Blue Water webinars, and we invite you to submit topics that you would like for our team to cover in future webinars, because we want to know what is important to you and your utility. Let us know how we can help you achieve your goals. You can reach us by sending an email to bluewater@jci.com or by using the QR code on your module. And thank you very much for attending the Blue Water webinar for October. Be safe, and we look forward to seeing you next month on November the 16th.